Alright, my guess is.
Let me double check.
Well, let's look in the box. If there's suppose there are only three different numbers. There's 1, 3, and 5. Okay. So let me just say, what if suppose this is a 1? Just for the heck of it. That means this has to be a 3 and a 5, right?
Yeah.
And that means that's another 1. That means these are 3 and 5. That means that's a 1.
Yeah.
That means these are 3 and 5 in some order, maybe. That's you sort of see what I'm saying? They're all the only factors this thing can have are 1, 3, and 5. So I don't know what this is, but let's suppose this happens.
1, 3, 3 diagonal.
Oh, it could be 1, 3, 3.
Yeah.
Oh, okay. But yeah, okay. Good point. 1, 3, 3. Where are you going to put it? Yeah, it could be 3, 3, 3, 3, 3,
Yeah.
3. Okay.
Stop.
Well, okay. How many numbers are in that box? 6 and 5. 6 and 6. There's 16 total numbers. How many ones are there total? There's 6 ones in the entire puzzle. There's 6 ones, 6 threes, and 6 fives. So does this number have to be the same? How can you make 16 out of 3 numbers? It could be 6 and 6 and 4, or 6 and 5 and 5, or that's it.
What about 16?
There's 16 squares to fill in, and I have to do it with 3 different numbers. I have to divide 16 into 3 piles.
Okay.
So, Tom, the big box will have 16 or 18 odd numbers, and then the 15 box in the corner will have the other 2 numbers, and there's 1.
Yeah, there'll have to be at least one. How do you make a 15? It can be 6, 5, 4 for addition. It can't be 1, 3, 5 because there.
No, sure cannot.
Because we're only missing 2 odd numbers in everything else, right? So you can get 15 by multiplying 1, 3, and 5, but that would use up 3 of the numbers. So this has to be addition. So that means, how do you get 15 in addition? 6, 5, 4 works. 6, 6, 3 works. That's it. So it's a 3 or a 5 lives somewhere in here. Yeah?
Won't have any extra 3s because there's 6 3s in that big number.
There are 6. How do you know that?
I factored it.
You factored. Finally somebody broke down and factored. Yeah. So what was the number again? 227. 8125. 8125. There's 6 3s and 5 5s. And 6 1s. I mean 5 1s. So you got 6 3s.
Then that has to go right down the diagonal.
Gotta get a 6 in every row and column, right? And the only way you can do that.
Why is that the only way?
All 6 of the 3s have to be in there. That's the only way.
1, 2.
Why would that be the only way?
Oh, if you zigzag them, right?
1, 2, 3, 4.
Alright, well let him zigzag and figure out where the numbers go.
Okay, so the 3s have to go in that.
Well, could the 3s go in any other way? I mean, how about 3, 3, 3,
What was the factorization, Emily?
3, 3?
6, 3.
3 to the 6, 5 to the 5th.
3 to the 6.
Yep, and then we'll have 5 1s for the other.
So we're missing 1 5 factor and 1 factor.
Yeah, 1 and 5.
Yeah, there's a 1 and a 5 missing. Oh, that actually tells you something. That tells you something. Remember, the 15 is what? It has to have the 5. Remember, it can't be multiply, so it has to be an addition thing. And how do you get 15 by adding 3 numbers? It's either 6, 5, 4 or 6, 6, 3. But we need to use we don't have any more 3s. So it has to be, this has to be 654. Well, let me just put it in here. First off, we know that for sure.
So I'm sorry, I wasn't always paying attention, so hopefully this wasn't already said. But in the big thing in the middle,
Yeah.
in each column, in each of the middle 4 columns and the middle 4 rows, we need 1, 3, and 5.
Yeah.
Yeah.
So that rules out in the bottom right corner the 5 from being anywhere but the corner.
Yes, you got a 135, 135, 135, 135, right? And so what are we missing? We're missing. We're missing a 1, 3, and 1, 2 3s and a 5.
Right, I see. But what I was saying is a conclusion about that bottom right corner now.
Yes. Oh, okay. Okay.
Like, say, look at the left part. It says 4, 5, 6, but we know it can't be 5 because.
Right. There can't be a 5 here. He's saying, right, because this is a 1, 3, and a. We have to have 1, 3, and a 5 here.
Right.
So that means this can't be a 5, and you have to have a 1, 3, and a 5 here. So that can't be a 5. So this is definitely a 5.
That's one thing we can agree on.
Yeah.